Artillery, the king of battle, since its first conception as ballistas and catapults, to gunpowder cannons, to now modern howitzers and even rocket artillery, it has defined the battlefields. As Napoleon once said,
God is on the side with the best artillery.
wait, we're not gonna talk about the history of artillery. We're gonna talk about how quadratic equations helps the military in using artillery. First, what is the military's use for quadratic equations? The military uses quadratic equations to determine where shells will land and missiles when fired from weapons or bases, such as launchers. Now, I need you to keep this formula in mind. Ax squared, or the quadratic coefficient, is equivalent to the gravity force. Bx, or the linear coefficient, is equivalent to the velocity, preferably meters per second. And c, or the constant term, is the height where it was launched. Now, let us answer this question. A mortar, 32 meters above sea level, fires a shell with a velocity of 206 meters per second and a gravity deaccelerates it by 30 meters a second. How long would it stay in the air? Now let us substitute and factor. Ax squared is equivalent to gravity deacceleration. Also, I made a mistake, so it should be negative ax squared is equivalent to gravity deacceleration. So meaning it turns into negative 13 squared, squ- 13x squared plus 206 because 206 is the velocity of the mortar. So it turns into 206x plus 32, which is the meter's height when the mortar fired its shell. Now after that we multiply it by just by negative, which turns into 13x squared minus 206x minus 32 is equivalent to 0. Now we factor, so it becomes 13x plus 2 equals 0 and x minus 16 equals 0, which after that we copy down 13x plus 2 equals 0. Then we divide it by 13, so meaning it becomes x plus 2 over 13 equals 0, which then we move, which becomes x equals negative 2 over 13 is equivalent to 0. Now, x minus 16 for x sub 2, x minus 16, then we move, which becomes x is equivalent to 16. And we have finally found our answer. The shell would stay in the air for 16 seconds. It can't be 2 over 13 because it's negative and it's also a fraction. I- It could, but it's negative. So the answer is the shell would stay in the air for 16 seconds. Thank you for listening to my presentation. Goodbye.